Hey everyone, so today we are going to move on to the next method for graphing quadratics. This is actually our last method, I think. This is the easy one too, which is nice. So I want you to pause and try the do now. It is a calculator problem. Alright, so a food truck sells salads for $6.50. Right, so $6.50 each for salad. And drinks for $2 for drinks. The food truck revenue from selling 209 salads and drinks in one day was $836.50. How many salads were sold? All right, so this is a system of equations. So it's $6.50 for each salad plus $2 for each drink cost. They made $836.50. And they sold a total of salads and drinks together 209. Right? So this is a system of equations. Pretty much on the SAT, it's important. Like, you can't just ignore these problems. There's multiple system of equations on every SAT. So you have a couple options here. What I'm gonna do is I'm gonna multiply the bottom one by 2. Because then we have our 650s plus 2d equals 836.5. And then under that, I'm going to write my 2s plus 2d equals 2 times 209 is 418. And then I'm going to subtract minus, so that the d's, the drinks, cancel out. So I get 450s equals, what is that? 4, I'm going to borrow 150. And then divide by 450, that I can't do in my head. So 418.50, whoops. 1850 divided by 450. 93. How many salads were sold? 93. Right? So it's a system of equations. We learned that in Algebra 1. It's not going to go away. We need to practice that if we want to do well on our SAT. Okay, so I want you to just find the vertex, right? How do you find the vertex of that parabola? So we always start with negative b over 2a. So negative 4 over 2 times 1 is negative 2. And then to find the y value, we plug in. Negative 2 squared plus 4 times negative 2 minus 3. I plug that in my calculator, and I get negative 7. So negative 2, negative 7 is my vertex. Now do the other one. Again, pause and try it on your own. Negative b over 2a, that's negative 12 over 2 times 1 is negative 6. Plug in negative 6, and I get 36 plus 12 times negative 6 minus 5. Plug that in my calculator, and I got negative 41. So negative b over 2a, plug in, that gives us our vertex. Okay. What is the vertex form of a quadratic? So if you remember, back when we were solving quadratics, I was giving you ones like 2 times x minus 5 squared equals 10 and stuff like that. This is actually vertex form. A parentheses x minus h squared plus k. When we're given a parabola, the vertex is in this equation. The h is our x. Now notice there's a minus here. So we will have to change the sign of the h, but the k is the outside number, and it stays the same. Okay, so all we're going to do is go through and write down what's our vertex. So instead of having to do negative b over 2a, when you see these parentheses like this, we know, oh, that's vertex form. So it's y equals a x minus h squared plus k. So my x value is just change the sign of the inside because of that minus. So instead of minus 7, it's 7. And then the y value is just this outside number, 5. All right, I'm going to do one more, number 4. The number out front doesn't matter, it doesn't change it. So it's just change the sign of the inside. Outside stays the same, minus 2. All right, I want you to do number 6 and number 8, and then we'll do 5 and 7 last. All right, so number 6, make sure you pause, do it by yourself. Change the sign of the inside, so instead of 11, it's negative 11. The outside stays the same, negative 15. Number 8, change the sign of the inside, minus 9. Outside stays the same, 7. Again, that negative in front doesn't change anything. Now, number 5. What's the inside? Is there an inside? There is no inside, so what is it? 0. Since there's no inside, it's just 0. My outside number is 4. And then number 7, change the sign of the inside, positive 12. Outside stays the same. What's the outside? There's nothing there, so that's a 0. All right, you can just put plus 0 there if you want. Okay, so let's make a table to look at this graph. So this is just plain x squared. So if we try to do negative b over 2a, there's no b value, so we just get 0. You know what? I'm going to add to this. I think I did it on your notes. We're going to add a few. So that my middle term is here. So I'm going to go negative 1, negative 2, negative 3, 1, 2, 3. All right, so then all we do is we square the numbers, right? Plug in. Negative 3 squared is 9. Negative 2 squared is 4. 1, 0, 1, 4, 9. All right, so then I'm going to graph it. Negative 3, 9. Negative 2, 4. Negative 1, 1, 0, 0. 1, 1, 2, 4, and 3, 9. All right, so there's my parabola. All right, so now, the reason we did this. Every parabola is based on this one, x squared. Y equals x squared is what we call the parent function. Right? Every parabola is basically this one parabola that's been moved. Let's see if it'll let me do it. Yeah, so imagine if when I change the vertex, all we're doing is taking this parabola and moving it to a new vertex. So say my vertex is there, that's the parabola. Say the vertex is down here, that's the parabola. So every parabola has that same relationship between all those points. So this distance from the vertex to this point is just over 1 up 1. The distance from this point to the 0, 6, over 2 up, 1, 2, 3, 4. It's all based on these numbers because we're squaring. So instead of doing all the work and plugging in and finding these numbers, we can just use this pattern of the relationship between the vertex, right, this vertex and all the other points on the parabola, right? Over 1 up 1, over 2 up 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to use that to graph our parabolas instead of making a table every time, because that's just too much work. All right, so every parabola is based on the parent function y equals x squared that has been translated to a different point on the coordinate plane. This means the distance between the points on the parabola and the vertex is the same, no matter where the vertex falls. So over 1, up 1, because this is y equals x squared. 1 squared is 1. Over 2, up 4. Over 3, up 9. Over 4, up 16. Now, we're not going to always be able to do all of those, but we're going to do the best we can. Usually we try to do 1, 2, 3. 1, 1, 2, 4, 3, 9. And we're going in both directions, right? I don't include the negatives because it's the same thing, but instead of going to the right, we go to the left. Also, we always count from the vertex. So this is different. Mrs. Larson teaches this a little differently. She doesn't count from the vertex every time. She does a slightly different rule. So if you're working with anyone in her Algebra 2 class, they might be doing it a little different. So don't get confused if you're working with a friend who has Mrs. Larson. Okay, so we're going to start off with our vertex. From before, what's the vertex? Change the sign of the inside. So instead of -2, it's +2. The outside stays the same. All right. So now our shifting rule, over, up. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. So we're going to start by plotting our vertex. 2, -9. So over 2, down, now, so I'm right here. And then what we're going to do is we're just going to go over 1, up 1, put a dot. Over 1, up 1, put a dot. So over 1, up 1, over 1, up 1. And then I'm going to go back to my vertex. So now I'm back to here. Now we're going to do 2, 4. So from the vertex, count 1, 2, 1, 2, 3, 4. So my dot goes there. Back to my vertex, over 2, 1, 2, 3, 4. Put a dot there. So over 2, 1, 2, 3, 4. 1, 2, 3, 4. All right, those are my next 2 dots. Now we're going to do it again with 3. 3, 9. So from my vertex, 1, 2, 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's where my point goes. And then do the same thing on the other side. Over 3, up 9. And then I can fit 4 16s. I'm going to do it. If it fits on my graph, I usually will. So 1, 2, 3, 4 over. Up 16. 9, 10, 11, 12, 13, 14, 15, 16. And there's my beautiful parabola. Okay, so now that we graphed it, let's write down what are the roots. Where does this cross the x-axis? So we have -1, 0, and 5, 0. What's the y-intercept? -5, 0, -5. The symmetric point, right, from -5, the other one, that's 4, -5. And that's it. A lot easier than all the other work we've been doing. Okay, so write down what is the vertex. So my vertex, change the sign of the inside. Outside stays the same. I'm going to write down my shifting rule, over, up. 1 squared is 1. 2 squared is 4. 3 squared is 9. So I want you to pause and try this one on your own. So I start by plotting -8, -4, which is right here. And then we're going to go over 1, up 1. So again, I count from my vertex, over 1, up 1, and then over 1, up 1. Back to my vertex. So I'm back here now, and I'm counting from my vertex, over 2, up 4. 1, 2, 3, 4. So I'm right there. And then do the same thing on the other side. 1, 2, 1, 2, 3, 4. Now I kind of ran out of space, but I'm going to do 3, 9 on the other side. So 1, 2, 3. 1, 2, 3. That was 4. 5, 6, 7, 8, 9. 7, 5. All right, so my roots are -6 and -10. Okay, now here's the tricky one. We don't know the y-intercept, right? We have no idea. It's not on this picture. What is the x value on the y-intercept? At our y-intercept, our x equals 0. So if we plug in 0, we get 0 plus 8 squared minus 4. That's 64 minus 4. That's 60. So we get 0, 60. And then remember, symmetric point, we double our vertex, so -16, 60. So that's a little tricky. The y-intercept isn't so easy to find when we're in vertex form. Okay. So what's our vertex? -5, 4. All right, now this one's a little harder. So I'm going to write down my shifting rule. Over, up, 1, 1, 2, 4, 3, 9. Now, what do you notice about this problem? We have a negative in front. What happens when we have a negative in front of our x squared? It goes down. So what we're going to do is, all we're going to do is instead of going up, we're going to just go down. Right? So -5, 4. So when you're counting, instead of going over 1, up 1, we're going to go over 1, down 1, over 1, down 1, over 2, down 4, over 2, down 4, over 3, down 9. So over 1, down 1, over 2, down 4, over 3, down 9. 5, 6, 7, 8, 9. And there is my parabola, which is upside down this time. All right, so my roots, where's this thing cross the x-axis? We got -3 and -7. Again, we need to plug into the 0 into the y-intercept. So we have -0 plus 5 squared plus 4. Now remember, when you plug in here, that negative in front isn't being squared. So it's -25 plus 4, so -21. -21. Oops. 0, -21. And think about it. If you accidentally squared it and you said 29, does it make sense that the y-intercept would be way up there, beyond that? No, that doesn't make sense. So pay attention to that. And then symmetric point, we double our vertex, so -10, and then the y is the same. All right, I want you to pause and try this one all on your own. All right, so I'm going to start with my over, up. I always write it down every time. 1, 1, 2, 4, 3, 9. You can write the 4, 16. You don't have to. Now this one has a negative, so it's going to be a down. My vertex, change the sign of the inside. Outside stays the same. So 2, 9, over 1, down 1, over 2, down 4, over 3, down 9, over 4, down 16. See, that was 9, 10, 11, 12, 13, 14, 15, 16. And there is my beautiful, easily found parabola. So my roots are -1 and 5. My symmetric point was 5. It's nice on the graph. And 4, 5 was the symmetric point. Cool. All right, I want you to draw a star next to this problem. I gotta see. Some people I don't think are actually listening, so draw a star. All right. Getting a little harder. Not too hard. All right, I'm going to start with my over up, just like always. 1, 1, 2, 4, 3, 9. Now, this one has a 3 in front. Remember what happened when we put a number in front of the x squared? It went up faster. So what that's going to do is it's going to multiply our y value. So I'm going to go over to my chart, and my up is getting multiplied by 3. So instead of 1 times 3 is 3. Instead of 4 times 3 is 12. Instead of 9 times 3 is 27. So all of those end up getting multiplied by 3. So the vertex, -1, -3. And I'm going to go over 1, up 3. Over 2, up 12. And that's all we can fit on here. So see that we have a super skinny graph. So our roots are -2, 0, 0, 0. My y-intercept is 0, 0. Symmetric point was -2, 0. X symmetry, x equals -1. I'm going to take that off, right? So the only difference here is it changes the up. We multiply the up by whatever number is in front of the parentheses. All right, last one. See if you can figure this one out on your own. Same idea. We're going to multiply our up value. So over, up, 1, 1, 2, 4, 3, 9. But we're going to multiply by -2. So this becomes -2, -8, -18. So notice, because it's negative, what's going to happen? We're actually going down, right? So my vertex, change the sign of the inside. Outside stays the same. So 7, 8. And I'm going to go over 1, down 2. Over 1, down 2. Back to my vertex. Over 2, down 8. Over 2, down 8. Back to my vertex. Over 3, down 18. And this actually does fit. Just fits. And there is my beautiful parabola. All right, so my roots are 5 and 9. 5 and 9. Now the y-intercept here is a little tricky. To find the y-intercept, I have to plug in 0. So -2 times 0 minus 7 squared plus 8. I'm just going to plug that in my calculator because that's too much work. 2 times -7 squared. Don't forget your parentheses. Plus 8. I got 106. Whew. Wait, that doesn't make sense. I forgot my negative. It's -2 times 7 squared plus 8. -90. I'm about to say 108. That would be up here, and there's no way that doesn't make sense at all. All right, so it is -90. Symmetric point, double my vertex, so 7 doubles is 14, and then the -90 again. All right, that's it. It doesn't really get that much harder. We can throw in some fractions for A, but this is it.